Welcome to AI Frontiers. Today's episode explores the robotics revolution, AI-powered machines in action, synthesizing 24 papers from October 30th, 2025. Cutting-edge advancements in robotics are examined, from real-time control to ethical human-robot bonds, highlighting innovations for real-world applications. This presentation provides a narrative journey through robotics research. A dive is taken into 24 fresh papers on robotics, blending AI with physical action. Themes like speedy decisions and team collaborations are uncovered. Key findings, methods, and future paths are spotlighted. Stories of robots catching pens or mapping moons are engaged with. This is perfect for enthusiasts curious about AI's real-world impact. The field of robotics is now overviewed. Robotics combines computer science and engineering for machines that sense, decide, and act in the physical world. Key elements include processing sensor data, like cameras or grippers for real-time responses. It draws from machine learning, control theory, and human interaction studies. Its significance lies in addressing labor shortages, dangerous tasks, and precision needs in healthcare, agriculture, and exploration. These 24 papers highlight AI-driven evolution toward adaptive, collaborative systems. Research Theme 1 focuses on real-time control and efficiency, boosting robot reflexes. A key theme is enabling instant reactions in dynamic settings, like catching falling objects. Ma and colleagues achieve 30 Hz vision language action models for multi-view tasks on consumer hardware. The focus is on pruning computations for speed without losing accuracy. This is relevant for assembly lines or emergency responses. It connects to broader efficiency in AI robot integration. Continuing with Research Theme 1 on real-time control and efficiency, high-speed applications are highlighted. Zhao and colleagues introduce hybrid policies decoupling speed from task diversity in manipulation. Trajectories at 480 Hz are achieved for feats like pen catching with 100% success. The technical concept involves streaming frameworks that process data in real time, like a continuous video feed for robot eyes. This impacts everyday robotics, from home assistants to industrial arms. It leads into themes of collaboration by enabling fluid interactions. Research Theme 2 addresses multi-robot collaboration, starting with unified frameworks. Another dominant theme is teams of robots sharing knowledge for scalable tasks. Tan and colleagues develop memory-based systems for lifelong adaptability across diverse robots. Failures are handled in settings like homes or restaurants via shared spatiotemporal memories. For example, bots coordinate chores seamlessly, improving fault recovery. This builds on efficiency by adding teamwork layers. Continuing Research Theme 2 on multi-robot collaboration, real-world scaling is examined. Vandermeer and colleagues apply collaboration to lunar mapping with resilient exploration systems. The technical concept involves embodiment memory that integrates physical traits and timelines, like a group brain for robots. It outperforms baselines in coordination and scaling for search and rescue. This ties into manipulation by enabling team-based handling of complex environments. It highlights overlap with learning for adaptive behaviors. Research Theme 3 focuses on learning-based manipulation and locomotion, advancing adaptive movements. The third theme centers on teaching robots tool use and stable walking via AI learning. Lee and colleagues create force-adaptive systems for humanoids handling intense contacts, like pulling heavy loads. Kothavale and colleagues use adaptive inverse kinematics for variable tools, recovering from errors. Reinforcement learning is explained as training a pet with rewards, but for robot policies to improve over trials. This connects themes, paving the way for key findings in practical applications. Key findings provide critical insights across papers. Real-time models achieve 100% success in dynamic tasks, debunking speed barriers, as in Ma and colleagues. Hybrid policies boost efficiency in manipulation, reducing steps by over 50%, as in Zhao and colleagues. Multi-robot frameworks enable seamless fault recovery and scaling, as in Tan and colleagues. Force-adaptive humanoids handle heavy interactions stably, as in Lee and colleagues. Ethical studies show anthropomorphism increases empathy, influencing design, as in various papers. The methodology synthesizes approaches in robotics research. Common methods include reinforcement learning for policy training in manipulation and navigation. Vision language models guide planning, integrating sight and language for tasks, as in Quan and colleagues. Sensor fusion techniques like Gaussian splatting are used for mapping and state estimation, as in Usweli and colleagues. Benchmarks and datasets test sim to real transfer, improving accuracy, as in Lee and colleagues and Lee and colleagues. Hybrid frameworks combine learning with control for efficiency and collaboration. Selected research paper 1 is Ma and colleagues 2025, titled Running VLAs at Real-Time Speed. The full title is Running VLAs at Real-Time Speed. It is selected for breaking computational barriers in vision language action models, enabling dynamic robot tasks. The novelty lies in achieving 30 to 480 Hz speeds on consumer hardware via pruning and streaming. The impact democratizes AI for everyday robots, representing the real-time efficiency theme. Justification is that it is pivotal for intuitive human-robot interactions in factories and homes. Selected research paper 2 is Tan and colleagues 2025, titled RoboUs Next, a unified memory-based framework for lifelong, scalable, and robust multi-robot collaboration. The full title is RoboUs Next, a unified memory-based framework for lifelong, scalable, and robust multi-robot collaboration. It is chosen for unifying team dynamics across heterogeneous robots, addressing collaboration challenges. The innovation is spatiotemporal embodiment memory for adaptability and fault recovery. It is representative of the multi-robot theme with real-world scalability. Justification is that it advances swarms for logistics and disasters based on practical warehouse insights. Selected research paper 3 is Quan and colleagues 2025, titled Kinodynamic Task and Motion Planning Using VLM-Guided and Interleaved Sampling. The full title is Kinodynamic Task and Motion Planning Using VLM-Guided and Interleaved Sampling. It is selected for bridging AI planning with physical feasibility in complex tasks. The novelty is interleaved sampling with vision language models for efficient long-horizon planning. The impact boosts success rates dramatically, representing embodied intelligence. Justification is that it is a key direction for hybrid systems in kitchens or factories, inspired by real failures. Future directions outline next steps in robotics research. Deeper AI fusions are expected for generalist robots via advanced reinforcement learning and vision language models to close sim-to-real gaps. Bio-inspired designs are anticipated for resilient humanoids and micro-robots in medicine and environment. Ethical frameworks will evolve for human-robot bonds, addressing emotional risks. Computational and safety challenges will be tackled with edge computing and interdisciplinary collaboration. This leads towards sustainable, inclusive robotics augmenting humans in diverse sectors. AI synthesis and review explain how this deck was created. The synthesis was created using AI tools including GPT-Grok, using model Grok 40709 for content generation. TTS synthesis uses OpenAI for audio narration. Image generation uses Google for visual elements. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided for further verification. Subscribe and channel info invite joining AI Frontiers. Subscription to the YouTube channel is encouraged for more AI research stories and insights. The channel title is AI Frontiers. The description is, stay updated on the latest in AI and robotics. Hit subscribe now. Thoughts on robot breakthroughs can be shared in the comments. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.